Deep within the ancient soils of Botswana, a land of vast wilderness and hidden treasures, miners at the Karowe mine unearthed something truly extraordinary. It was a diamond, but unlike any seen before. This remarkable stone, weighing a significant 37.4 carats, held a secret within its crystal structure. One half of it shimmered with a delicate, beautiful pink hue, a color highly prized in the world of gemstones. The other half, in stark contrast, was perfectly clear and colorless, as pure and transparent as a drop of morning dew. It was a single, unified crystal, yet it displayed two completely different natures side by side, in perfect, astonishing harmony. This geological marvel, which has since been named the Beating Heart, immediately captured the attention of geologists and gemologists around the world. It was a puzzle crafted by nature, a single stone that posed 1,000 questions. How could such a perfect division of color exist within one diamond? The stone was sent to the prestigious Gemological Institute of America, or GIA, for careful and detailed examination. There, a team of dedicated scientists, led by experts in diamond formation, began the long and patient process of unlocking the secrets held captive within this unique and beautiful specimen, hoping to understand the story it had to tell. The initial examination confirmed what the miners had first witnessed. A clear, almost surgical line separated the pink and colorless zones. It was not a gradual blend or a mottled pattern, but a stark and definite boundary. This suggested that the diamond had experienced two very different sets of conditions during its long and complex formation deep within the Earth's mantle. It was as if two separate geological stories had converged and become one, frozen in time within this single breathtaking crystal. This was not just a beautiful gem. It was a scientific artifact of immense importance, promising new insights into the planet's hidden processes. The mere existence of such a stone challenges our understanding of how these precious gems are born. Diamonds are time capsules, messengers from a world we can never visit, a world of unimaginable pressure and heat, hundreds of kilometers beneath our feet. Each one carries a tale of its journey, but this particular diamond spoke with two distinct voices. Its discovery in Botswana, a region known for producing some of the world's most magnificent diamonds, adds another chapter to the country's rich geological history. The Beating Heart was not just a discovery of wealth, but a discovery of knowledge waiting to be deciphered. The allure of a pink diamond is not just in its beauty, but in its mystery. Unlike blue diamonds, which get their color from the element boron, or yellow diamonds, which are colored by nitrogen, the origin of the pink hue is far more dramatic. It is the result of immense, almost unimaginable stress. As the diamond crystal is forming deep within the Earth's mantle, it can be subjected to intense pressure and strain. This physical stress can twist and distort the diamond's internal crystal lattice, the perfectly ordered arrangement of carbon atoms. This distortion is what gives the diamond its magnificent pink, or in some cases, red color. What makes the Beating Heart diamond so incredibly special is that this intense color-creating event happened to only one part of the stone. Imagine the process. For a brief moment in geological time, one side of the growing diamond was squeezed and twisted with colossal force, while the other side remained untouched, continuing its growth in a more stable, tranquil environment. This is an exceptionally rare occurrence. It suggests a very specific localized pressure event that affected the diamond's formation. It's a geological snapshot, capturing a moment of extreme turmoil next to a moment of perfect calm, all within the same tiny growing crystal. The scientists at the GIA used advanced spectroscopic techniques to study the stone. This allowed them to analyze how light interacts with the diamond's atomic structure, confirming the presence of these strain-induced distortions, known as plastic deformation, exclusively in the pink half. The colorless half, by contrast, showed a pristine and undisturbed crystal lattice. This confirmed that the diamond did not acquire its color from trace elements, but from a powerful physical force. The stone is a direct piece of evidence, a testament to the violent and dynamic processes that occur in the Earth's upper mantle, a place of constant slow-motion change. This split personality is what makes the beating heart a scientific wonder. Usually, when a diamond-forming region experiences such intense strain, all the diamonds within it are affected. To find a single crystal that was only partially subjected to this force is like finding a fossil that is half bone and half living tissue. It provides a unique opportunity for researchers to study the exact boundary conditions of these color-creating events. It allows them to compare side by side the strained and unstrained portions of the same crystal, offering a perfect natural experiment that could never be replicated in a laboratory. The story of any diamond begins in a place of mythic proportions, the Earth's mantle. This is the thick layer of rock that lies between the crust we live on and the planet's molten core. Here, at depths of 150 to 200 kilometers, the conditions are almost beyond comprehension. The pressure is over 50,000 times greater than at the surface, and temperatures soar to more than 1,000 degrees Celsius. It is in this extreme environment, over periods of billions of years, that carbon atoms are squeezed together with such force that they bond into the incredibly hard, crystalline structure we know as diamond. These precious crystals are trapped in this deep, hidden world for eons. They are prisoners of the mantle, waiting for a very specific and violent event to bring them to the surface. Their escape route is a special kind of volcanic eruption, one that is incredibly fast and powerful. These eruptions originate from deep within the mantle, far deeper than typical volcanoes. They blast upwards at supersonic speeds, carrying a slurry of molten rock, minerals, and the diamonds themselves. This rapid ascent is crucial. If the journey were too slow, the diamonds would simply transform back into graphite under the changing pressure and temperature. The molten rock, known as kimberlite or lamproite, cools and solidifies into long, carat-shaped vertical structures called pipes. These pipes are the primary sources from which most of the world's diamonds are mined. Miners excavate the hardened rock from these ancient volcanic conduits, searching for the gems that were delivered from the depths millions or even billions of years ago. The Karowe mine in Botswana, where the beating heart was found, is one such kimberlite pipe. It is a direct channel to the Earth's distant past, a geological elevator that has brought these timeless treasures into our reach. The beating heart diamond, therefore, is not just a stone. It is an ancient artifact that has completed one of nature's most epic journeys. It was born in the fiery belly of the early Earth, was subjected to immense and specific forces, and was then rocketed to the surface in a geological instant. Every facet and every flaw tells a part of this story. Understanding this journey helps us appreciate the sheer improbability of a diamond's existence. Each one is a small miracle of geology, a survivor of a billion-year-long odyssey through the heart of our ever-changing planet. This remarkable half-and-half diamond is more than just a curiosity. It is a vital clue for scientists seeking to understand the Earth's deep history. The mantle is a dynamic and convecting system, with vast, slow-moving currents of rock that have been churning for billions of years. These movements are responsible for plate tectonics, the process that shapes our continents and oceans. By studying diamonds, which are formed within this system, scientists can find direct evidence of the conditions and events that have occurred in the mantle over geological time. The beating heart diamond provides a uniquely clear and precise piece of that puzzle. The sharp boundary between the pink and colorless zones tells a fascinating story about the mantle's environment. It suggests that the diamond may have been growing in a region where two distinct mantle domains met. One domain was stable and calm, allowing for the formation of a perfect, colorless crystal. The other was a zone of intense geological stress, perhaps related to the collision of tectonic plates deep within the Earth, which twisted the growing crystal and gave it a pink hue. This diamond, therefore, could be a physical record of a tectonic boundary frozen in time, from billions of years ago. This discovery helps geologists to map the geography of the deep Earth. By understanding where and when such stress events occurred, they can build more accurate models of how continents have formed, drifted apart, and collided throughout our planet's history. Diamonds often contain tiny mineral fragments known as inclusions, which are trapped during their formation. If such inclusions were found at the boundary of the pink and colorless zones, they could provide even more information about the specific chemical and physical conditions that defined this ancient mantle frontier. This single stone acts as a probe, giving us data from a place we can never directly access. In the grand narrative of our planet, the beating heart diamond is a beautiful and eloquent paragraph. It speaks of a dynamic, sometimes violent, but always creative world, hidden far beneath our feet. It reminds us that even the most solid and timeless of objects, like a diamond, are products of change and transformation. For researchers, this stone is a source of immense excitement. It is a tangible link to the processes that shaped our world, offering a clearer understanding of Earth's past and, in doing so, helping us to better comprehend its present and future. It is, in every sense, a true jewel of science.